Continuity, part 2. Question number 1. Find the relation between a and b so that the function defined by f is continuous at x equal to 3. Function is fx equal to ax plus 1 when x is less than or equal to 3 and bx plus 3 when x is greater than 3. So, LHR, limit x tends to 3 minus ax plus 1. We put the value of x as 3. So we get 3a plus 1. Suppose this is equation number 1. Then RHL, limit x tends to 3 plus, and this time we have to take function bx plus 3. So it will become 3b plus 3. Equation number 2. Now, for function to be continuous, LHL must be equal to RHL. So 3a plus 1 equal to 3b plus 3. 3a minus 3b equal to 2. This is required relation. Let's go to question number 2. If the following function is continuous at x equal to pi by 2, then find a and b. Function is fx equal to 1 minus sine cube x divided by 3 cos square x when x is less than pi by 2. It is a when x equal to pi by 2, and it is b times 1 minus sine x divided by pi minus 2x whole square when x is greater than pi by 2. LHL, limit x tends to pi by 2 minus 1 minus sine cube x divided by 3 cos square x. So limit x tends to pi by 2 minus, here we can apply a cube minus b cube formula. A cube minus b cube is equal to a minus b times a square plus b square plus ab. So it will become 1 minus sine x times 1 plus sine square x plus sine x divided by 3. Cos square x can be written as 1 minus sine square x, and then we factorize it, so that will give 1 minus sine x into 1 plus sine x. So 1 minus sine x into 1 plus sine. 1 minus sine x will cancel out. Now we can put the value of x as pi by 2. So we get 1 plus 1 plus 1 divided by 3 times 1 plus 1. It will be 1 by 2. So we have got LHL as 1 by 2. Now here value of function is a, which means a will be equal to 1 by 2. So another thing we have got a equal to 1 by 2. Now we consider RHL. So limit, let's write RHL, limit x tends to pi by 2 plus function is b times 1 minus sine x divided by pi minus 2x whole square. So RHL will be equal to limit x tends to pi by 2 plus b into 1 minus sine x divided by pi minus 2x whole square. So here we assume that suppose x minus pi by 2, x minus pi by 2 equal to y. Then 2x minus pi equal to 2y. So when x tends to pi by 2, y tends to 0, because when we put x equal to pi by 2, so pi will become 0. So we can say limit y tends to, here it is pi by 2 plus, so y tends to 0, and this will become b times, in place of x we can write y plus pi by 2. So 1 minus sine y plus pi by 2 divided by, denominator will become y square. Sorry, here pi minus 2x equal to 2y. So pi, it will become 2y square. So we write it further. So sine 90 plus theta gives cos theta. So answer is limit y tends to 0 and b times 1 minus cos x divided by 4y squared. So this will become limit y tends to 0 and then b, and this can be written as 2 sine square x by 2 whole divided by, so sorry, it is not x, it is cos y. So this is y by 2 divided by 4y square. So here we can make sine square by 2 as 1 because limit is 0. So in that case, what do we get? So it will become limit y tends to 0 b times 2 sine y upon 2 divided by y upon 2 whole square, and then y square by 4 whole divided by 4y square. So this will become 1, and y square will cancel out. This 4 will become 16. This 2 will cancel this. So we have got b time b in numerator only, and then this will become 4 to 8, b by 8. So we have got RHL as b by 8, and LHL was a by 2. So we can say that b by 8 is equal to a by 2. From where? Sorry, not a by 2, but 1 by 2. So from where b equal to 4. So we have got the answer a equal to 1 by 2, b equal to 4. Now consider next question. Show that the function fx equal to 2x minus modulus x is continuous at x equal to, here fx equal to 2x minus modulus x. Now we consider LHL, limit x tends to 0 minus 2x minus, or 0 minus modulus x will become minus x, because if you remember, if fx equal to modulus x, then it becomes negative x if x is less than 0 and positive x if x is greater than 0. So This will become minus x. So limit x tends to 0 minus 3x, which will give 0. Now consider RHL. RHL will be limit x tends to 0 plus 2x minus x, because for 0 plus x will be modulus x will be positive x. So limit x tends to 0 plus it is x, that will give 0, and the value of function f0 will give 0. Hence LHL equal to RHL equal to value of function all are 0, and so we can say that function is continuous. Now, for what value of k is the following function continuous at x equal to pi by 2? So let's consider the solution. So we are given fx equals k cos x divided by pi minus 2x, where x does not equal to pi by 2, and it is 3 when x equal to pi by 2. LHL limit x tends to pi by 2 minus k cos x divided by pi minus 2x. Let x minus pi by 2 equal to y, or x equal to y plus pi by 2. Now, when x tends to pi by 2, y tends to 0. So this becomes limit y tends to 0, and here this will become k times cos. In place of x, we can write y plus pi by 2 whole divided by. This will become from here pi minus 2x. If we multiply by 2, so it will become 2x minus pi equal to 2 pi. We are given pi minus 2x, it means minus 2 pi. So limit y tends to 0, and this will become cos pi by 2 plus theta gets minus sine theta. So minus k sine y divided by minus 2y, which is equal to minus, so minus will cancel out, k by 2 into sine y upon y, that is k by 2. So the same answer we will get from RHL also, because same thing we have to do, except here we will write pi by 2 plus. Here one more thing can be considered. Since this is x minus pi by 2 equal to pi, and limit is tending to pi by 2 minus, then y will tend to 0 plus. Instead of this, we have to write here 0 plus. So we have got LHL as k by 2. Similarly, RHL will also be k by 2, because from same function we have to evaluate LHL and RHL. And this must be equal to value of function at pi by 2. So k by 2 is equal to 3, or k equal to 6. Now, let's consider one more question. Or what value of k is the function f continuous at x equal to 0? So we are given fx equal to 1 minus cos 2x divided by 2x square when x is less than 0. It is k when x equal to 0, and it is x upon modulus x when x is greater. So LHL limit x tends to 0 minus. Consider this function 1 minus cos 2x divided by 2x square. It will become limit x tends to 0 minus 2 sine square x divided by 2x square. 2 will cancel out. So this will become limit x tends to 0 minus, sorry, sine x upon x whole square, and that will be 1. So we have got it as 1. And the value of function at x equal to 0 is k. It means k equal to 1. Let's also evaluate RHL. So RHL limit x tends to 0 plus, and this time we have to consider this function, and for x greater than 0, modulus x will become x. So we will get x upon x, which is 1. So we have got LHL as 1, RHL as 1, and the value of function at x equal to 0, k, which means k equal to 1. Hence the answer. Thank you for watching.